Hello, and welcome to another module of our course of Universal Application Development on Windows Platform. And today we will discuss how to create an application which consists of different pages and how to navigate between them. So first of all, if you need to create an application with different pages, you need to add a new page to your application. For this, you go to Project, Add New Item, and you add New Empty Page to your application. So new page would mean that you create a new XAML file and you create new code behind file. Both of the files are created simultaneously in the same manner as you have main page.xaml when you just create an empty application. So to navigate to this page, anywhere in your code, you use frame.navigate and you specify the type of the new page. So you say frame.navigate type of new page, and it shows up in your application window. In most of the cases, you would want to pass parameters between pages. So for example, in the weather application, when you have the forecast, you want to click on a specific date to get more details for the weather. And you would need to specify on which object you clicked and pass this information to a new page. So this can be done in several ways, but the most used one is the following. In fact, frame.navigate can accept a second parameter. So the first parameter is always the type of the page, and the second parameter can be any object. It's an arbitrary object of the type object, and you can pass it to frame.navigate, and on the new page you can retrieve it. The easiest way to retrieve it on the new page would be to override the onNavigated_to function. And when you override it, you receive the navigation event args. And navigation event args contains the field called parameter. It would be a field of type object. So you would need to convert it to the actual type. So for example, if you passed an object of type myObject, you would need to convert this to myObject. And if it's converted fine, then you can use this later on inside the page. But there are also other ways to pass the data between pages. For example, if you have the common data model, of course, changes made in data model by one page are reflected on the other page. So you can just expect that you change the data model and then the new page would display already the new data. You can do this through application settings. Application settings is something to which all pages have access. You can use, of course, file storage. You can use a static class with a singleton pattern. For example, you can create a class and then one page can assign values and the other one can retrieve them. All of that can be useful, for example, if you need to pass more data than just one or two simple parameters. But if it's just one or two parameters, they can be passed in the way that I have described before. Now let's see how this technique can be used to improve our application and to use to show weather forecast with details for any specified date. Having learned how to create new pages, let's add a weather detail page to our application so that whenever we click on a weather for a specific date, we can get more detailed forecast. So in order to do this, we open our project and add new window. We say add create element, and we use blank page, and let's call it details page. So you see the page is created similar to the main page with its own design. Now to add the navigation to this page, what we need to do is we need to change the property of the grid view. So grid view has a number of events. So whenever we select an item, there is an event which can get fired. So let's try to find the appropriate event. It's called item click. So whenever I click on an item, a function is called. And in this function, we will add the actual page navigation. So I would say frame.navigate. Then I say type of details page. And what we also need to do here, because grid view by default does not enable item click, even though we specify here the corresponding handler. We should specify also explicitly is item click enabled equals to true. That's a little secret which can save us a lot of debugging time. So now let's see how our application works. I start it up. I would need to wait a little bit for the weather to come up. And here it goes, the current weather, the forecast, and when I click on the day, you see that we are actually navigated to a different page. But this different page is empty, so we just need to do two things. We need to create the design of that page, and we need to pass the parameter. So what would be the best way to do it? So the best way to do it would be to pass the parameter here, because actually the second parameter in frame.navigate can be any object. So what I will do here is I would pass here e.clickedItem. And you can probably guess that the type of e.clickedItem would be weather detail, because our forecast is populated with objects of the type weather record. So the type would be weather record, which is quite good because weather record contains all the required information for the corresponding date. So what I will do, I will pass the weather record which I have selected to the new details page. So what I will do at the details page, I would create a property which will hold the weather record. Here in the page class, I would say public weather record data, and that would be a property. And whenever I open the page, the easiest way would be to override on navigated to function. And here I receive e.parameter is the corresponding object which I have passed to the page navigation. So I can say data equals to e.parameter as weather record, because we can expect the type to be weather record. And if something is wrong, in this case data would be null. In this case I can throw an exception. So that's just to make sure that everything works fine. So now let's come to creating the design of the page. The design of the page can be quite simple. I can put, for example, the date in the top and then the list of parameters below. So let me then format the table manually. I would create equal width of columns. And for rows, the first one let it be 100 elements. And then I would need rows for temperature, pressure, and humidity. And those would be, for example, 30. And then for the rest. And now let's do the formatting. So the main column would be text block. So the date would go to the top. So grid.row equals to 0. Grid.column span equals to 2. It would be the whole width. And then let it be big. So font size 40. And this one would be bound to data. So I would say x.bind to data dot full date. Now let's see if it works, just to make sure. I will click on the page, and you see actually now the date is correctly specified. So now what I need to do, I would need to type the fields for all of the other fields. I will skip this for a moment. So here are the data fields. I would put temperature, humidity, and pressure to the first column of the table, and then the actual values to the first column of the table, to the second one actually with the number 1, and I will bind it to data.temperature, data.humidity, and data.pressure. Also, to make everything look more beautiful, I would add an extra space around the big grid. So I'll put margin equals to 20 here. Now let's see how it works. Oh, there is an error here. Data.temperature. Maybe I mistyped the field name. So what is it? It's data.temp. Exactly. You see, one of the big advantages of the static binding is that all the errors can be discovered early at compile time. So here I would say data.temp. Good. Let's now hope that it works. That is our application, and for 4th of October, you see I see the temperature, humidity, and pressure. Let's not care too much about the design for the moment, because we will be able to adjust it and improve it later on. But we have done the main task. We have created the second page of the application, and we have created, we are now able to pass the parameter from one page to another. So you may have noticed that in our application, when you navigate to a second page, there is no way to return back to the first one. And in order to do that, you need to handle back navigation properly. Let's discuss how you can do that. So, in fact, for mobiles and tablets, navigation is done a little bit differently. Mobiles and tablets, they have a software back button, and mobiles, sometimes they have hardware back button as well. So this software back button can be handled, it is normally handled by the operating system. But if you have a desktop, the desktop with multiple windows does not necessarily have the back button. So in your desktop application, you need to think how navigation would be done. So you can actually manually add back button to your page. For example, you can create a button which would navigate you back to the first page. Or you can use the standard button on the application title bar. In modern version of Windows, in fact, you have the navigation, you have the way to turn on this button, so that this button would be visible in the upper left-hand corner. Both methods depend on how you would like your user interface to be structured. If you want full control, you can manually add a button. If you want user to find the button in the place where he usually expects to find it, then you are better off using the standard button. Now let's discuss how you can use the standard button. So in order to do it, you basically need to say that it should be visible. The best way to do it would be to use rootFrame.navigated event, and inside this event you can create the System Navigation Manager, and in the System Navigation Manager you can define whether button should be visible or not. You see this System Navigation Manager for current view, which we have retrieved in the variable called nav, it contains the property AppViewBackButtonVisibility, which can be true or false. If it's true, the button is visible. So the easiest way to set it would be to check with the root frame whether can go back equals to true, and in this case make button visibility visible. The way can go back works is that it checks whether the previously navigated stack of pages is empty or not. Once you have shown the back button, you need to define a property which would work when you actually press a button. So pressing a button should normally take us to the previous page inside the application, and that's why um, it is up to us to write this logic. It is by default quite complicated because, for example, if you press back button on the first page of the application, then application is suspended, and if it's split screen, then you have two navigation stacks and so on. But in the simplest case, it's basically enough to maintain just one navigation stack, which contains the references to pages which have been shown to the user previously. So going back is basically as simple as taking the top of this stack and navigating to that page. And in most cases, in most scenarios, this should be sufficient. So to add this logic to your application, you still need to write it manually in App.xaml.cs. With System Navigation Manager, you register to this back requested handler. So this back requested handler is called whenever you press the back button, be it a software button or be it a hardware button, automatic button, or the button which you display in the top left corner of the application. And once this happens, you can manually check whether you can go back. The stack is not empty, and if it's not empty, then you just call frame.goback. It's pretty simple logic. It should work in most scenarios, but you should definitely check your application if it handles back button correctly for all your scenarios. What we will do now, we will add handling back navigation to our weather application. Let us now handle the back button in our application. You can see that in the current design of the application there is one big problem, because when we press on the date, there is no way to go back to the first page, only closing the whole window, which is not good. So in order to do this, let's first show the back button. And whether back button is showed or not is controlled in the App.xaml.cs file. There is a very useful function called onLaunched, which actually is executed at the startup of the application. So let's do one thing at the end of the startup. Let's define the event which executes when we navigate to the current frame. So we'll say root frame.navigated, and we add a special event. I will create the function automatically. So this event would fire when I navigate to this page. So this happens when I navigate to the root page. Now in this code, I would need to do the following. Let me use a little bit code snippet here. So the idea of this code is the following. I check, I get the root frame of the window, and then I check whether app view back button visibility it's the property which defines the visibility of the button. So basically I can say equals to true, and this would mean that the back button would be always visible. But on the other hand, I do not want to show this back button for every page. Like for the first page of the application, I definitely do not want the back button. So what I do here, I check whether the property can go back is true. So actually what happens here is that every application maintains the stack of the pages that it has visited. And in the beginning, this stack is empty. So this root frame.canGoBack is false. And I choose the button to be collapsed, so the button would not be visible. When I navigate to a different page, the old page URL goes to the stack, and canGoBack becomes true, and the back button becomes visible here. So if I now run my application, what I will see is that the default back button, which is drawn by the Windows UI, should be visible on the second page. So you see the first page is the same. When I navigate, I actually see the back button here. But back button does nothing. It does not navigate back. So for it to navigate back, I need to define a handler. So again, in this onNavigated_to function, I do the following. I use System Navigation Manager .get for current view. I get the instance of the manager for current view, and I say back requested. That's the event which happens every time that back button is pressed. So let me define this event here. And this event would work in the following manner. Let me find the correct place to put the code. It's a little bit difficult, sorry. So here it is. So when I press the back button, what happens is that first I check whether this event has not been handled yet, because it can propagate through several handlers. Now, if the event has not been handled, then I get again the reference to the current frame. And if I can go back, I just call the go back, frame.goback. And I check the e.handle so that to indicate that the event has actually been taken care of. So that's a simple logic. If I add it to my App.xaml, I would automatically be able to handle the back events in my application. So now it should look pretty much complete. I can, from the main page, check the weather for 4th of October, then go back, check the weather for the 3rd of October, and so on. It looks pretty good. Why do I need to write all this by hand? Why this is not built in? Well, first of all, you can build it in, and for example, you can build an extra class which would and then inherit the app.xaml from it, and this can be easy to add this functionality. But on the other hand, sometimes you need a little bit different logic for handling pages. So in UWP you have a lot of flexibility. This simple logic can handle quite a lot of scenarios, but sometimes stack is not enough. So you should be always careful to check how your application reacts to back button. That's pretty much it for navigating between windows, but let's also discuss one not very traditional case when the application contains several windows, or if you want to manipulate your application window on the lower level. So to manipulate application window, there is a special object called application view. So application view, you can always retrieve the application view object for current view. And then it contains methods which would allow you to set minimum size of the window, resize the window, go full screen, and so on. So setting minimum size of the window is quite useful. For example, if you are sure that your object would not fit nicely on a very small screen, you can set the minimum size, and it would not allow user to resize it below this size. It would happen automatically. You don't need to create any logic for that. You might also want to run with a specified fixed size, like for example, if it's a calculator which was designed to look beautiful on a certain resolutions, you can resize the window to this exact size. But keep in mind that it might not always work. If it's a universal application, if it's running on the phone or in a full screen mode, then you would not be able to resize the window, and this method try resize view would not work. The same is true for full screen mode. So you can try to enter full screen mode, but you are not guaranteed that it would work. Let's see a small example of application which uses those methods. Let's see a simple example of window manipulation. I will show you already existing application, which would allow us basically to control the window. So the application consists of a number of buttons. The main design is a grid with buttons. Now I will probably see it in a second here in the constructor. So it would contain buttons for resizing the window and for several other things. So let's see how it works. I will define the size of the window to be 500 by 500 pixels. That will be the initial size of the window. And I would create the object called application view. Now, when the application initializes, I get the application view for current view. So I would say application view dot get for current view. So AV would be the object to control my application. And I would do try resize view to the new size of 500 by 500 pixels. So try resize view would try to do it. If my application is running full screen in the tablet mode, it might not succeed. But if it runs on the desktop, it would resize it to this size. And then I have the button click handler. It's the same handler for all buttons. And my buttons, you can see there is an interesting feature here. For each button, I define a special field called tag. Tag is basically a field which can be of any type, and I can assign it to any object in XAML hierarchy. So in my case, the tag represents the amount of pixels that I need to move the window. For example, when I press the button called up, I would need to move it 1 pixel up in the Y direction. And X is the same. So this simplifies parsing a lot, because all buttons in this case, they have one handler. And in my button handler, I basically get this tag, I split it, and I get dx and dy by just parsing the first and second parts of the tag. And if I get that dx and dy is 0, which means I press the button in the middle, I try to enter the full screen mode. So if application is in full screen mode, I exit full screen mode, and if it's not, I try to enter full screen mode. And if dx and dy is not 0, I actually try to resize the window. So let's see how it works. I start the application, and initially the size of the window can be anything. I can resize it, for example, but when the actually application starts, the first thing it does, you will see it in a second, it resizes the window to 500 by 500 pixels. And now, by pressing the buttons left, right, up and down, I can actually resize the view. And F would bring my application into the full screen mode. You see it's full screen, but I still can get to the window handler. And then if I press it again, I exit full screen mode. So that's very useful technique for you if you want to create full screen applications which try to get full users' attention. You can try to use this technique to make them look the way you want. In fact, application can have several windows. So, for example, if you have a graphical editor and if you want the tools palette and the main area for the application to be separate windows, you can do that. And to do that, you use the special classes in Windows application model.core application. So those classes, they contain some very basic and low level functionality, which you should not normally touch, but in this case we can try to see how it works. So to create a new view, you basically use create new view, which gives you a reference to a new frame, to a new view where you can load manually a new frame. So what you normally do, you create a new view, you load a frame, a page into it, and then you try to show it as standalone or switch a sync to switch to this new window. So you can control which one of the windows of your application would have focus. And what's nice is that those methods, they are available on all device types. They just might behave a little bit different. So you should definitely check how your application works with multiple windows for different device types. I will also show you a short example of using this function in your application. There is also one more button in my application which creates a copy of its main frame. Let's have a look. When the application starts, if I click on N, I create another copy of the same window. So you see now my application can run into different windows, and actually it resembles two copies of the same application running side by side. And I can also create a few more. So how do I do it? Let's have a look. Let me close the copies and see the code. So it's this click of the button. If I press the N button, what I do, I create Windows application model core application, and then I create a new view. So new view would be a new window. And for this new view, I get the reference. So that's the core application view. And I can use a dispatcher to run the code in the thread of this application view. So what I do, I say v.dispatcher.runAsync. So I run the code inside this new view. And inside this view, I create a frame. I navigate to the page. In this case, I navigate to the same page of the application, but I can, of course, navigate to any other page. And then I do basically the same kind of code which is used in App.xaml. I create and I activate it. So that's basically it. And then in this dispatcher code, I try to get the ID of the application. And after exiting it in my main thread, I try to switch, try throw a standalone async. So what happens is that I give focus to this new application, and it starts working as a separate one. So in this case, you can create multiple applications which has multiple windows, similar to graphical editors, for example, when you can have one window for toolbox and another window for the main place where you manipulate image. So you can create quite complex interfaces. But you need to keep in mind that in table mode, all those techniques would not look very good, because in the full screen mode, all those windows would be displayed either full screen or in a split view side by side, which may not be exactly something that you want. So if you try to use those complex techniques, you need to make sure to check how your application works in table mode. So the conclusion: application consists of several pages, and most of the real-life application, in fact, do consist of several pages. Each page is basically a separate XAML and code behind file. You can use frame.navigate to navigate between those pages, and you can pass parameters between them. And if you do navigate, then you need to take care of correct back navigation. You can either take care about it yourself by creating corresponding buttons on the page, or you can use specific code snippets which we have seen to use automatic stack-based frame navigation. And also, of course, you can have multi-windowed applications with multiple windows, but make sure they work correctly on different device types. So see you soon in the next module.